So good day everyone, I'm Engine Cadet Carl Hamasis Picaranzo, and today in this video I'm going to share to you the 4 laws of thermodynamics and their application on board. So let's proceed. Zeroth law. Zeroth law of thermodynamics: if two thermodynamic systems are each in thermal equilibrium with a third, then they are in thermal equilibrium with each other. If object A is the same temperature as object B and object B is the same temperature as object C, then object A is the same temperature as object C. This seems obvious, but this is the foundation for measuring temperature. So onboard application: ensuring accurate temperature readings across different instruments like engine temperature gauges, refrigeration units relies on the zeroth law. If all gauges are calibrated correctly, they should show consistent readings if measuring the same temperature source. So let's proceed to the first law, which is called the law of conservation of energy. Energy cannot be created or destroyed. It only transferred or changed from one form to another. Simple explanation of this: the total amount of energy in a closed system remains constant. Energy might change form, like chemical energy to heat energy in combustion, but the total amount stays the same. So onboard application: understanding energy transformation is crucial for efficient engine operation. The chemical energy in fuel is converted into mechanical energy to propel the vessel, with some energy loss as heat. Analyzing this energy conservation help optimize fuel efficiency and reduce waste heat vessels. So power generation system like generator, solar panels also follow the first law. The energy source is converted into electrical energy. So let's proceed to the second law, which is called the entropy. Second law of thermodynamics: the total entropy of an isolated system can only increase over time or remain constant in ideal cases, where the system is in a steady state or undergoing a reversible process. The simple explanation: these things tend to become more disordered over the time. Imagine a deck of cards. It's highly ordered when new, but after shuffling, it becomes disordered. It's extremely unlikely the cards will spontaneously rearrange themselves into perfect order. Entropy is a measure of this disorder. So onboard application: the second law explains why engine requires continuous fuel input to maintain operation. Heat generated by the engine increase the entropy of the surrounding, like ocean, water, and air. Maintaining a co-engine requires energy input to counteract the natural tendency towards increase in disorder and heat dissipation. Efficient waste heat management. So systems are designed to minimize entropy, increase and improve overall efficiency. So let's proceed to the third law, which is called the entropy of a perfect crystal, and absolute zero temperature is zero. So the simple explanation of this: at absolute zero with negative 273.15 degrees Celsius or 0 Kelvin, the atoms is in a perfectly ordered crystal have zero entropy. This is a theoretical concept, as absolute zero is unattainable. So onboard application: the third law is less directly applicable to everyday onboard operation than the other laws. However, understanding low temperature behavior of materials is relevant in